So that concludes part 3, and then part 4 will be just a brief recapping, identifying the challenges of climate engineering, and we've already discussed those in connection with individual technologies, and then the dangers, and not just technological dangers, the sort of human factors involved as well. So the first thing to note is that the environmental effects of the majority of these technologies are unpredictable. If they start to be manifest, then you cut back on the technologies, alter them or abandon them. Second concern is global versus local. We know that climate change is a global externality, as economists would call it, right? That heating is a bad thing, and so each individual through their activity, like driving a car, is imposing costs on others. But what matters to individual people is the temperature and the sea level and so on, where they live. So ideally, if you implement climate engineering, the effects would be uniform across the surface of the Earth. But it's very hard to accomplish that, and clearly something like a space mirror would not, right? Because the umbrella, the shadow of the mirror is just localized in a small fraction of the Earth's surface. Most of these technologies, if deployed, will involve benefits and costs, and the benefits ought to exceed the costs, otherwise they're not worth implementing. But the problem is that there's going to be uneven distribution. There'll be gainers, particularly people who are already suffering severely from climate change, and if technologies are used to alleviate that, they'll gain the most, and this will be typically lower income developing countries. And then there are going to be losers, and it's very hard to identify any kind of policy, whether it has to do with the climate or transportation or healthcare, where every single person or group of people win. Inevitably, there are going to be some losers, and they may well express their dissatisfaction with an idea. So that's an obstacle which would have to be overcome somehow. Public outreach, or maybe some kind of compensation, whether it's in monetary terms or some other method. So that, I think, is one of the major hurdles to climate engineering. And then specifically for solar radiation management, yes, these technologies can reduce the heat, but they don't do anything to reduce the carbon dioxide concentration, or the ocean acidification, or the sea level rise, and the other effects. So people would still have to adapt to that. It's just that you're going to have cooling in certain locations, so one of the manifestations of climate change would be alleviated. And then if the solar radiation management technologies, such as the aerosol injection, turn out to be bad, then you can stop them. But then there's no longer any positive effect, and changes could have occurred in the interim. Maybe the farmers deciding to grow new crops because it's cooler, but if the cooling effect ends, then they're back to where they started, and they'll have incurred an adjustment cost which they can't recoup. So it's be unfortunate if people are induced to change their behavior at a cost, and then they have to go back to the previous situation. Then the final point to make is that there are incentive problems from the perspective of individuals, governments, and even continents. And the first is a well-known one called the free rider problem. And that arises because climate engineering, if it's implemented correctly, is a global public good. So perhaps not everyone in the world will benefit, but a large number will. But the costs have to be incurred by whatever countries or states implement it. Right? So all the costs are concentrated and the benefits are diffused. And that creates an incentive problem because players of this game, corporations or countries and so on, have an incentive to free ride, right? Leave it up to others to undertake these costly measures. And that's a problem, of course, not just for climate engineering, but other behavioral changes, simply like conservation. Do I really want to lower the thermostat in my house to 15 degrees centigrade during the winter? The effect is, of course, very small from the global perspective. Well, people might say they do it, but they don't actually. They keep the temperature at 20 degrees centigrade. So free riding is a problem, and countries would have to come to some kind of agreement in the form that if we do it, then you better do it as well. So either we do it in concert, or perhaps nothing happens. And so you end up in status quo. Second problem is one that's been widely discussed, and that's the moral hazard problem. So let's suppose these climate engineering technologies are deployed. Well, people say, The problem is largely being solved, so why should we pursue other costly measures, such as conservation or whatever? So let me cut back on that. Right? And that means that the methods of combating climate change won't be optimal. Too much is being spent on the technology of engineering, and too little is being spent on other behavioral dimensions, which may be like low-hanging fruit. They're cheaper to deploy per ton of carbon emissions, and it also it means that you'll get less of the cheaper activity. If indeed the climate engineering doesn't work, then you'll have lost time. Right? That doesn't work, and the conservation efforts were cut back. So that would be actually worse than nothing. And then the final point gets into ethics or morality, and some people consider altering the environment through methods like climate engineering ideologically wrong, even if it has no adverse technological, climatic, or economic effects. And there are certain groups who have that view. So that's it. The remaining slides in this presentation are just the references, some of which I've cited on the slide. So thank you very much.